All right. Hello and welcome everybody to Howdy Partner, our weekly Twitch series hosted live here on the AWS Twitch channel. So every week we use these 2 hours to showcase our amazing partners in the AWS Partner Network and the innovative solutions that they build on AWS. Now, who am I? My name is Jerry Tejada. I'm a partner solutions architect at AWS. And a big part of my job is just reviewing architectures developed by the amazing community of partners and customers that we have here at AWS, and just helping them improve their solutions by using our best practices. And joining me here today from the AWS side is Brian. So Brian, get in here and say hello and tell us a little bit about you.
Howdy, everyone. I'm Brian Kreitzer. I'm a partner solutions architect here at AWS. I partner with NVIDIA to help our customers and partners deploy NVIDIA software solutions on AWS. So that includes topics like today, which is around NVIDIA's Gen AI SDKs, frameworks, and models, along with Omniverse.
Awesome, Brian. And this is your first Howdy Partner. Is that correct?
It is my first.
All right. Well, we are ecstatic to have you here. Brian is awesome. And where's everyone tuning in from? I'm in New York. Brian, where are you shooting from right now?
I am south of San Francisco, so representing Northern California.
All right, all right. Let's get it going in the chat here. Let's see a couple comments of where we're tuning in from in the audience. I'll wait a second to see what we've got. I will not start until somebody tells me where they are. We've got a shy crowd here today. I'm in New York. Okay, we've got Mexico. Thank you for our viewing audience in Mexico and wherever else you are. Okay, we got the one. Let's go ahead. We can move on. Hopefully we get a little less shy because we want to hear you in the audience. You know, we want this to be really interactive. We want this demo to be, you know, asking questions and just really engaging with us here. So please do use the comments for any questions you have and anything that you see here today. All right. Well, you know who we are and you know where we are. Now let's talk about today's guest, who we are very excited to have here on the show, and that is NVIDIA, ladies and gentlemen. So on today's episode, our partners at NVIDIA will show us how to use their NeMo framework to build, customize, and deploy generative AI models. That's right. We said it, Gen AI, which has taken the world by storm in the last year. And with good reason, you know, because it is a pretty transformational piece of technology, I must say. All right, so today with NVIDIA's NeMo, hopefully you learn a little something about how to wield this powerful piece of technology and put it to use for your business. And specifically, we're going to talk about how to run NeMo on AWS, because that's what partnership is all about. Us at AWS and our partners at NVIDIA helping you, the customer. You know, whether you're a large enterprise, small business, even a single developer, you know, wherever you are, we want to work together to help you reach your end goal and make your business better. Okay, so that's enough of us. Let's bring in our friends here at NVIDIA. Let's get them to join the party here. Charlie, Nirmalya, hello. So please tell us about yourselves and tell us a little bit about what we're going to be seeing here today.
Thanks, Jerry and
Hi,
Brian.
Charlie, go ahead first.
Thanks, Jerry and Brian, for having us. Really excited to be here. I'm just going to kick it off real quick, and then Nirmalya is really going to be our main event. But I'm from the NVIDIA Enterprise AI Product Marketing team, and Nirmalya?
I'm from the NeMo LLM product team.
Awesome. Thanks so much, guys. So if you could just let us know, what are we going to be seeing here today? I know we introduced NeMo, but if you could just tell us and the audience what we have in store for today's episode.
So thank you for joining today. You know, my job is finding NeMo, as I often say. It's very hard. We have a lot of NeMo assets, NeMo framework, NeMo models, NeMo service, NeMo guardrails, NeMo retrievers. So today we are going to see NeMo framework in works and working on AWS, on EKS, how to build, customize, and deploy a Gen AI model, as Jerry you mentioned, that is taken the world by storm. We're going to see all that, not only talks, also in actions. We're excited to take your questions and looking forward to this session.
Amazing. Thanks, Nirmalya. So let's bring this on the screen here.
Oh, do you want to share mine first, Jerry?
Sure. Yeah, of course.
Yeah, so hopefully some of our Howdy partner audience had a chance to attend reInvent. Maybe if you could raise your hand or chime in if you had a great time there. But if you attended or you listened to the stream of the keynote, our two CEOs presented a lot of exciting stuff. And what we're showing here is essentially just a summary of what was announced by our two CEOs back at reInvent in November. And so what we're going to focus on today is really, if you look at that middle layer, and this is really our AI software products. So you have the NeMo that Nirmalya will talk about in detail today. And that's actually in a software AI end-to-end platform that we offer called NVIDIA AI Enterprise. And this is available on the AWS Marketplace page. And really, Gen AI, it's across every industry. No matter what industry you're in, you're going to touch Gen AI. And here we're just showing some of the different use cases, and a lot of them they'll cross, like customer service, improving customer service, improving just experiences overall, optimizing your business operations. That could go across. But here it shows just some of the use cases that each of the industries will use, how the industries will use generative AI. And as I mentioned, NVIDIA AI Enterprise is this end-to-end software platform that NVIDIA offers on AWS now, that you could see that you'll use from an end-to-end perspective. NeMo is our generative AI large language model set of frameworks and tools that Nirmalya will cover. And so I just want to give a quick overview of just this whole end-to-end AI software that NVIDIA offers on AWS that's accelerated by the infrastructure that you could get on AWS with all the different GPU instances that are available. And so as I transition to hand it over to Nirmalya, this is just an overview of what you're going to hear about and see today. It's called NVIDIA NeMo, and it's an end-to-end platform for generative AI for building and customizing models and deploying and scaling your generative AI. And so with that overview, I want to hand it off to Nirmalya to dive deeper into NeMo. Nirmalya.
Fantastic. Thank you, Charlie, setting up that awesome background and the partnership between AWS, Amazon as a whole, and NVIDIA. We really, really like and, really appreciate that partnership. So, Jerry, if we can go to the slide. Yes, thank you. Thank you. So I'll spend a little bit moment, but you see, my name is not coincident. My name is Nirmalya, very closely resemble with NeMo. So that's the reason, one of the reason I guess I was recruited to be in this NeMo project. But jokes aside, this is NVIDIA's kind of the main focus on the Gen AI. And if you are thinking of Gen AI journey, there are 6 predominant steps. One is data curation and data creation, foundation model training, continuous training, instruction tuning, and customization and deployment. And when you were thinking that, you were really thinking, how can I do that? How can I do that at scale? and hence NeMo framework comes to play. And one kind of, you can use either one component and or all components to be part of your LLM journey. And after you deploy, there are two things which have also taken the world by storm, to borrow Jerry's word: RAG, retrieval augmented generation, and guardrails. So in NeMo, we have not been, we have been looking into those opportunities, and we are providing solutions to create a great RAG solution, as well as provide guardrails, which kind of guards the conversation, such that the conversation remains within a specific domain which is of your interest, not it starts hallucinating, such that when you ask a question, it answers something completely differently. We are very proud to be partnering with Amazon and AWS in these, our NeMo framework training and inference container are certified and validated on AWS. In fact, I can go even more. I can extend that comment to say that Amazon themselves are training large language models using NeMo framework. There's a public blog which was published in reInvent. We are very proud of that partnership, and that is probably the best validation of NeMo framework, as you can imagine. If Amazon is training their own model, large models, probably I'm sure you will have more confidence that just I'm speaking about it. One of my colleagues, if they can share the link about that blog, that would be great. So moving on to the next slide. When we talk about the large language model has many modalities. When we started this journey, all of us started this journey, probably we thinking about text, predominantly text. But as we see the future, we are looking into the multimodal. And multimodal means mixed, more than one modality, because multimodal is an overused term. So what we mean by that is text, image, video, audio, motion, animation. And we do not know, many more multimodal capabilities may come out. And in the world of truly multimodal, you can think about in one of these, any one of this input can go in, and any one of the input modality come out. Meaning you can put text, you can get image, you can input video, you may get a text summary of this. So that is the real world of multimodality, and NeMo framework, probably with humility, I can say that one of the best frameworks anywhere available to train, deploy, and customize your multimodal models. I'll go through this section very quickly because the topic of today's session is customizing and create your custom models. But in any large language model journey, probably you think about the data curation is most important. If you think about, if you're creating a foundation model, you may be starting with 300 terabytes, huge amount of data, and ultimately will be ending up with 2 terabytes. So that kind of cleaning you are looking at. And it's not easy to do that kind of cleaning without a very sophisticated programmatic approach. So basically we're looking at to kind of get rid of the bad text, extraction of JavaScript, extraction of HTML. You were trying to look at what is a good document, what is a bad document, what we call query filtering or classification of the document. And then you were trying to look at, okay, how many duplicates in a document? So we go through deduplication, and then you were putting the data blend, and then you were getting to train. In fact, if you're thinking about if you're training a model which is focused on email, you want to see that email, between the paragraphs, there's a 1-line spacing, and between the signature line and the last paragraph, there are 2-line spacing. So all those minute details you will be thinking about, and where that information you want to put about. You want to put that information in the data curation module, such that the data is proper. When the data is trained, the data properly knows what kind of data it needs to collect, clean, and curate. So that's very important for us. This module is accelerated CPU and on GPU, and we have provided this module for pre-training. And with the latest container, we are going to provide this module for SFT, which is instruction tuning, as well as we are providing this module for PFT, parameter efficient fine tuning. We really believe lots of you can benefit from this module. I'll not spend a lot of time because there are not a lot of companies who are doing foundation model training. But if you are one of them, one of the brave hearts who are looking to train 15 billion, 20 billion model with trillions of parameters, that's what generally these days are talked about. You need many GPUs, and you need the GPUs to talk to each other. Basically, their techniques got tensor parallelism and pipeline parallelism, which is, which NVIDIA is quite good at because it's very close to the, runs close to the GPU. So basically, we're trying to optimize the throughput and minimize the latency. As you can imagine, these runs take a lot of compute. There is a MIT study, which I obviously quote. This is not our numbers and MIT numbers. A reasonably large LLM takes about $10 million of compute. So you can think about, if you do not converge the model, if you choose wrong parameters, there's a huge financial loss. So we are very careful. We try to provide you the right guidance such that your models converge at the right time. And then also, once you look at the compute part of it, you want to optimize the memory part of it, right? So the sequence parallelism and selective activity computation are the two techniques which optimizes the memory. So in combination of these four techniques, tensor parallelism, pipeline parallelism, sequence parallelism, and selective activity computation, you will be able to get a reasonably converged model within the expected period of time. And we will optimize your GPU utilization. So this is quite important, and we do provide a tool called auto configurator. So essentially, when you know that what kind of model you are trying to build, what GPU infrastructure you have, you feed all those information, and we look at the auto configurator, and we do a grid search, and at the end of that, we come out with what is the proper parameter of tensor parallel, what is the proper parameter of pipeline parallel, what is the batch size will look like. These are very important for your model to converge. We do provide lots of models, and we do optimize lots of models. So that's one of the very important aspect of NeMo. Of course, and we do not say that we always create the greatest models. We do create models which happen to be great, like Nemotron 3, 8B, 22B, and 43B. These are trained with about 3.5 trillion tokens, and as you know, knowing from Gemini and others, the companies are building models with 8 trillion, 9 trillion tokens, which is unimaginable, right? There is a paper which says that human knowledge ends at about 4.9 to 5 trillion. So you can imagine these models are so powerful, so much synthetic data has gone into this. But the point of NeMo, what I like to make is, if you happen to like a model Llama, if you happen to like a model Star Coder, we take those models, we optimize the model through the entire NeMo pipeline. So such that when you are thinking about Llama 2, you may be thinking about .NeMo Llama 2. But basically it means is when you start training, it's about 1.5 to 1.7 to 2x faster through the NeMo pipeline, because we have the mechanism of transformer engine and whatnot. That's what increases the training speed. And when you are doing the inference, probably one of the best inference engines are TRT LLM, so that during inference time it is optimized, so you might expect 2.5 to 3x faster. So that's what's kind of the message of this slide is: take the best models, what you like, or from us, we will make sure the models are most performant at the training as well as the inference time. And finally, I want to talk about NeMo Retriever, because all of us talking about RAG, retrieval augmented generation, and there are two models work on RAG. One is, of course, the generator model, which is the LLM, and one is the retriever model. Creating a great retriever model is not an easy thing. It depends on how quality the data set is. Also, it depends on the technique. So in NeMo framework, we do provide technique to create NeMo retriever models as well as fine-tune a retriever model. Those are very recent innovations, and we want to make sure that we do support the RAG pipeline as appropriate. Now, getting to the customization, the journey of the customization has been interesting, because we have seen that they're great out-of-the-box models. Companies have expectation they can do a little bit of prompt engineering, and they can tune the model for their use case. Then you can see a segment of companies who want to do a little bit of customization, and then they want to condition the model for their use case. And there are companies like who want to do a lot of customization, up to probably fine tuning to maybe foundation model training. Depends on your appetite, depends on the availability of your data set, and depends on what exactly you are trying to do. I will be the last one to suggest that always customize or create foundation model. That's not the right solution. Right solution is whatever the use case for you, look at your use case. Does it make sense? And what kind of techniques make sense? Our job at NVIDIA, our job at NeMo framework is to provide you the tools such that you can get the most performant and most accurate derived or conditioned custom model for your use case. So this is a slide. If you forget everything of this presentation, remember one slide, probably this one I'd like you to take away with you, because since the topic is, how to create custom models. So we are providing various custom techniques. One is, of course, the prompt engineering, which is not custom technique per se, which is on the extreme left, and it needs a very less compute, which, you play zero shot, you just, feed a prompt or feed a couple of prompts, and then you get the results. Essentially, you are conditioning the model at the time of inference. So that's what the inference type. Then you say that, okay, now, I'm still not getting it. I want to condition the model a little bit more. The techniques most commonly used are p-tuning and NVIDIA. There are two techniques, p-tuning and prompt tuning, and NVIDIA prefers p-tuning. And we have found for most of the tasks, p-tuning works very, very well. Then if you go to a little bit more, which is the talk of the town today, LoRa, low-ranking adaptation, almost everywhere you see, companies are training or customizing with LoRa, dynamic LoRa, Q LoRa, Eta LoRa. I can go on and on. That technique also is very popular these days. We are providing those techniques. Once again, coming to the major philosophy that our goal is to provide you the most current and efficient techniques such that your custom models are great. And you will find we are not only providing the techniques, we are providing the scripts and recipes such that you can take advantage of those techniques. And finally, we do also provide playbooks. There are, if you look at the documentation, there are playbooks and all that. And lastly, if you're brave enough, you say, no, parameter efficient tuning is not sufficient for me. Then you want to go to instruction tuning. Instruction tuning is SFT, supervised fine tuning, RLHF, which all know the greatness of ChatGPT or that kind of model is those models are trained with RLHF and reinforcement learning with human feedback. And it knows how to talk to human. It knows how to respond to human. It speaks like a human. It responds like a human because it has gone through a lot of training like that. And I'll spend a little bit of time on RLHF. And NVIDIA has recently published a paper called STRLM. Essentially, you can think about supervised fine-tuning on steroid. You want your model to steer to a certain direction, like to create a much more verbose response, to create a much more humorous response. And those kind of things, you can do this with STRLM technique.
Nirmalya, quickly,
yes,
before we move on, if we could hop back to this.
Of course.
Slide.
Oh, sorry.
No worries. So we had a question in the chat.
Sure.
Couple actually. So by p-tuning, are we referring to PEFT? I'm assuming that means the parameter efficient fine tuning there.
Someone, there's an argument where it falls, but for this sake of the discussion, Jerry, yes, p-tuning, PFT is a family of training techniques. Parameter efficient fine tuning is a family of training techniques, right? And you can consider p-tuning can fall under that family of PEFT. PEFT, basically, you can think about p-tuning. If you look at Hugging Face PEFT, right, which everybody refers to, or if you look at our documentation, p-tuning, LoRa, adapter, Q LoRa, Eta LoRa, those are the kind of very common adapters. As parameter efficient tuning with IA3, which works very well with Korean languages. So those are the kind of techniques which falls under PEFT.
Awesome, thank you. We actually had one more.
Sure.
And thank you for helping out in the chat here. So curious what prompt learning is. We all hear about prompt engineering, but is prompt learning a new terminology?
Thank you. Probably with NVIDIA, we have to be. I will talk to Charlie after this call on getting better branding and marketing. Originally, when NVIDIA started this p-tuning, we came up with this technique called prompt learning, which essentially included those two techniques, p-tuning and prompt tuning. But for the all intents and purposes of this discussion, I think we can club those and LoRa and IA3, parameter efficient tuning with IA3 under PEFT. So prompt learning is NVIDIA coined terms in the probably I will say in the early days of 2023 when GenAI is moving in such a speed. Now it says I have to say even 1 year is a little bit earlier. So we came up with this term prompt learning. But nowadays, we can mention, if you look at Hugging Face, within parameter efficient fine tuning, the industry includes p-tuning and prompt learning as a part of PEF technique.
Great. Thanks for that, Nirmalya. And this is great, by the way. You can tell how passionate you are about this topic. You're just beaming off the screen. I love it.
No worries. So if I can move on. So this is the reinforcement learning with human feedback. We wanted to spend a little bit of time on that because this is everybody focused on, what's the RLHF look like? Let me tell you one thing. Training a RLHF model more than 20 billion with a multiple nodes is not a job of event of it's not an easy job. It's not a trivial job. So that is something we are very, very careful, right? Because the models are 200 billion, 300 billion, 70 billion, 100 billion. To provide a solution at that scale of an RLHF is because you have to make sure the model is converging, the model is performant. And why it is so difficult? There are 4 models working at simultaneously, as you can see in this slide. There is a reward model, there is a policy model, there is a critique model, and there's an agent, right? So those 4 models working in tandem. And once all these 4, you can see the process. I'm not going to bore you with the process. You can read, but it's first you supervised fine tune, and then you create the reward model, then you put through those chain, and then you ultimately start doing when you do the inference, you take the SFT model, which has been informed by the reward model, which is a right response, which is a wrong response. So when you're asking a question, it does know from previous reward system that which answer it is supposed to give it to you and which answer it is not supposed to give it to you, right? But overall, we can have another dedicated session on RLHF. How do we think about it? But this is very, very important to understand why this is critical and why we find at NeMo framework this is an unique offering by us. Means almost all other providers are our partners, but once again we pride ourselves, can say that probably NeMo framework is probably the only framework which we can fairly say that which can do RLHF at a very large scale, like 200 billion parameters with a convergent and with a efficient output. And this is the last slide probably on the customization block is the STRLM, which is a part of the instruction tuning. You can think about supervised fine tuning on steroid. Supervised fine tuning on steroid. Basically, you are steering the conversation to your liking. So this is how a STRLM technique works. Is basically you are feeding. You're feeding different attributes, and you will see in the demonstration, and with the different attributes you continue to improve the steerability of the LLM. Essentially, as I mentioned, it's a technique of supervised fine tuning. So here is I'll take a zoom out approach and think about this way. You create a foundation model. Foundation model is kind of great, but it does not know how to talk. It has all the knowledge, but it does not know how to communicate to the knowledge. Now you start doing supervised fine tuning. Now it starts knowing how to communicate to you. Now you know how to communicate to you on general, like, if you say that, what is the dosage of this medication? It will say something. But you tune more And then you ask, what is the dosage of this medication for 2-year-old? Then it knows more to answer for the 2-year-old specific way, right? Is 5 milliliter versus 15 milliliter. So the point what is similarly when for the STRLM, you see you kind of supervised fine tune the model with different steerability, and you can condition the model so at the inference time the model will be able to know how to produce humorous response, how to produce verbose response. This is very popular in the video gaming character. I'm not saying you should do like violent character generation prompts, but but video game characters are not always very nice, right? So you can create various flavors of the responses of your gaming characters. So this is another technique. So in summary, if you look at the journey when we started, and I really like you to give you the time with the demo, and then I will come back on the other side to answer all your questions, because we want to hear from you, as Jerry mentioned, not only I speaking. Starting the knowledge, you can do pre-training or continuous training. Bloomberg GPT is a great example of continuous training. They took the foundation model, they forgot the 50% of the original knowledge, they put about 50% of the finance knowledge, and at the end, it has become a finance GPT or Bloomberg GPT, right? So those are the kind of considerations you will make when you are thinking about that kind of a training. And then I also mentioned, right, if you want to do continuous learning, is the reinforcement learning is a technique. If you are trying to do for a skill or for a task, you should think about parameter efficient fine tuning, and we'll talk about guardrails in a moment. And one of the very important thing is, especially these days, how to understand bias and how to understand toxicity. This is absolute paramount importance. We are working with largest countries. There are 40, 50, 60 countries who are building country-specific ChatGPT. We call it sovereign LLM, right? And for each country, the concept of bias is different. For each country, the concept of toxicity is different. Similarly, for each company, your use case, the bias and toxicity is different. So we do provide script and techniques such that you can provide, guidance to the output. Is it a toxic output? Is it a biased output? So all those, if you look at the NeMo framework, we provide something called toxicity filter. We do not make the judgment call, by the way, what is toxic to you. We provide you a toxicity score. And it is your duty to understand what is the threshold you like to put, because we should not be in the right position to make judgment call for you, what is the toxic and what is not, right? So that's something we are guided by, especially for this product. I'll not spend, this product is used worldwide, one of the leading frameworks. As I mentioned, we are very proud with AWS and Amazon partnership. They're training their own large language model with this framework. Korea Telecom has another, and they're across the globe. There are many partners. ServiceNow, they're customizing a large language model for ServiceNow IT help desk ticket summarization. So they're interesting use case. ServiceNow does like lots of IT help desk, right? And if you know those tickets, 7 pages, 8 pages, but you really want to know what's the summary of those. So that's a unique work we are doing with them with our NeMo framework. So in a nutshell, we are very proud to be, partnering with AWS. The containers are certified on AWS. We do provide multimodal. We do provide various model architectures, and 100 billion plus. Of course, we do support smaller models. There is BART, which used to be called in NLP. Now we are seeing a lot of applications of that coming into LLM in a very large format, and we are now providing support for mixture of experts. Probably all of you, the Mixtral model, which also was very popular, Mixtral X. So that is a MOE model. And as I also mentioned, we do support retrieval. From the orchestration side, which will be the demo point quite a bit, that we do support Kubernetes and Slurm. And the demo you will see is when we do a custom training with LoRa on Kubernetes on EKS. So that's another very important point. It's not that we are kind of prescribing, rather than we are giving you choices. Either you choose Slurm or you choose Kubernetes or what have you. In fact, on the CSPs, we have seen much more adoption on the Kubernetes, especially on the training side. Kubernetes was not that popular, but recently it is getting a lot of popularity, and you will see that in action. So with that, I want to give the mic to Paul to talk about the demo and to go through the demo. And I hope you enjoyed the demonstration, and then I'll come back on the other side to answer your questions.
Paul. Hi, how's it going? I'm Paul Gibbons. I'm a solutions architect at NVIDIA, and I primarily work with large-scale language model training. And the demo that we're going to show you today, it's from one of my coworkers, Huang. He's put a lot of great effort into this, and he will be walking you through how to properly use NeMo on EKS. So he's going to show you all how to spin up an EKS cluster, how to start an EFS file system, and then how to do any of the configuration changes needed to use NeMo on EKS with an EFS file system. So Jerry, when you're ready, you can take it away and start the video.
Yep, definitely. We'll do that. Just before we jump into that, we got a few more questions in the chat. Paul or Nirmalya, if you don't mind answering. First, we got, is the Steer LM based on direct preference optimization, DPO? And is there a paper on Steer LM?
Yeah, so we can share a link to the paper in the chat. But then the best way to think about Steer LM, it is like, say when you look at RLHF, you, like Nirmalya was saying, you need to have, say, 4 different models. The way Steer LM works is you're training a model to, say, predict these certain attributes on a data set, how creative you want like this like response to be, how angry you want this response to be, how like other type of more like steerable emotions. And then what you'll do is you'll train a model that predicts those attributes, and then you'll annotate your data set with that model. And then you can go through the site, like say the standard supervised fine-tuning approach. So you won't necessarily have to use, say, 4 different large models to do your RLHF. So it's a much more computationally efficient process towards, say, fine-tuning your model.
Amazing. Thanks for that answer, Paul. And then one more, 2 more we've got here before we jump into the demo. I know we're all dying to see this demo. So next question, how does NeMo deal with hallucination, and can it be used for law and compliance use cases?
Nirmalya, you want to talk a little bit about guardrails?
So yes. There are 2 ways to deal with hallucination. One is the pre-training, and one is the post-inference. So the post-inference will talk about the guardrails, which has become popular. So you see, we provide something called NeMo guardrails. It's an open source GitHub repo. So we do provide 3 guardrails: topical, security, and safety, such that you are constrained within your guardrails. If you're asking a HR chatbot question, such that it does not answer who won the Olympic swimming race last year. So it makes sure that it remains topical. But our key goal is to provide you with the ability to create your own guardrails. So besides these 3, and another principle we are driven by, if you remember those days of dialogue creation, there'll be a spaghetti-like code of if then else. If you do this, you don't do this. But we have taken that to our heart, and our guardrails is written in a very simple, declarative, pure English language. The programming language called Golang, CO. But it's a very just declarative English language. If you do this, just don't do that. Very simple. You can give it instruction, and it learns from instructions because it is using LLM in the back end, and that's how we can prevent hallucination. But that's the after inference time. On the before inference, that's why we talk about all the things we just talked about, right? 3 things. You can condition the model as much as you can for your use case. So the propensity of getting a wrong answer is little less. Second, we do provide all the scores, log probes, cumulative log probes, as a part of the response. And you can decide, right, what is the right threshold for you. You can choose what you want to do, what you do not want to do. And even on the data curation side, that is another thing. Why did we create the data curator module? Exactly to address this question. So that when you are feeding data to your model, fine-tuning data, you are feeding the right amount of data. Having said that, have we solved the problem of hallucination? No. Because I just mentioned, right, it has seen 3.5 trillion tokens. It's very hard, but we are trying to provide as much tools on the training side and after inferences that we can guide the conversation. But I completely accept and recognize there's much more work to be done in the hallucination space.
Thanks so much for that, Nirmalya. All right, let's do it. As promised, as we do here on Howdy Partner, let's see a demonstration of NeMo that we've talked so much about. So I will add that other screen here.
Okay. Thanks, everyone.
So Paul, are we just gonna go ahead play the clip?
Yeah, that'd be perfect.
Fantastic.
For coming today. My name is Huang. I am a solutions architect at NVIDIA for about 2 years now. And in today's demo, I'll be showing you how to run NeMo framework training job on AWS EKS. NVIDIA NeMo is an end-to-end cloud-native enterprise framework for developers to build, customize, and deploy generative AI models with billions of parameters. The framework provides an accelerated framework for training with 3D parallelism techniques. It offers a choice of several customization techniques and is optimized for at-scale inference of models for language and image applications with multi-GPU and with multi-node configurations. NVIDIA NeMo framework has Kubernetes implementation for a local Kubernetes cluster. And in today's demo, we'll try to move this local Kubernetes cluster onto AWS EKS, a cloud cluster. And in order to do that, we will need to create two components in advance. So the first one is setting up an EKS cluster. The second part is setting up an EFS file system. And the EKS cluster is your Kubernetes cluster, basically, but it will be on Amazon EKS and it will be on cloud. The EFS file system / the second component will be the network file system that will be shared up in your cluster. So every node in your cluster will have access to it and they can read and write simultaneously on it. We want this feature because when your model is training in NeMo, for example, at every 100 steps, you will save a checkpoint onto your drive, and we want it to be on an EFS file system so that every node can write to the same place, and also we can view it whenever we want from another machine. And that's the whole purpose of having this EFS file system. And this is also required in the NeMo Kubernetes. If you don't have file system set up, it will be really hard for EKS cluster to work for multi-node. Okay, so without further ado, let's go right into the first step, how to create EKS cluster. And I have already created a YAML file here called cluster.yaml. This YAML file shows you how to actually run an EKS cluster. At line 11 and 12, this is where you specify your AMI for your instance. We want this specific AMI because not all AMI supports NVIDIA GPUs. This is the software component. If you have chosen a instance that has NVIDIA GPUs on it, but you don't have the right driver set up or / the right AMI on it, you still won't be able to use it, and your training job will fail on NeMo. So we want to use this right AMI here. And just one quick note here, this AMI ID here will change based on your different regions. In this case, we are using US-West2, but in different regions, this number will be different here. At line 14, we tell EKS that I want to create two nodes of G5.12x large. So G5.12x large has 4 NVIDIA A10G GPUs on it, and we want 2 nodes. So in total, we have 8 GPUs. At line 15, this is where we specify how large we want the volume size to be. We're setting up as a 200 gigabytes. For today's demo, 200 is more than enough, and you can change it based on your specific workload. Okay, everything else here is pretty standard. If you just want to have a quick example that can up and running, you should be able to just copy this. And we are all good in this YAML file. So how do you actually use this YAML file? This is the command. So use eksctl. Make sure you install all these command lines on your machine, and make sure you have your AWS account configured. We'll cover them in the write-up and also in the blog format later in a step-by-step way. This is the command that we want to use to create a cluster. And here we just specify use this file as the config and run it. So I have already run this command beforehand. So once you have this set up, once you have the command finished up running, you should be able to see them in, or if you want, you can view them in web UI. And keep in mind that this step can take up to half an hour, maybe longer, but at least it's been half an hour for me. So just keep in mind that it might take a while. And once you have this ready, you should be able to see them using this command. So if you type in kubectl get nodes, you can see that, okay, we already have IP address was this for this node, and the second node is this different IP address. And they're ready, they're in good conditions, and the age has been 7 hours and 49 minutes. I run this beforehand, so it's been running for this long. And we can pretty much make sure that, we can pretty much say that EKS cluster is up and running here. But if you want to, you can also view them on a web UI. So on your AWS web UI here, if you go to EKS, you should be able to see your cluster. This is the name that we just created. And if you click on it, and here has all these details for your cluster, you can view them here. And if you go to the third tab on compute, here tells you what nodes you have in your cluster. And we can see that we have for WinHand-node group number 1, this node group 1 has 2 nodes here, and each one is G5.12x large, just like we specified in the YAML file. And it's been running for 8 hours because I've run this before the demo today. And so this should be good. This means EKS is up and running. And that covers the first part of the demo today. The second part is to create an EFS file system. And Amazon has a step-by-step guide to show you how to create EFS for your EKS cluster specifically. And we will show them later. We will share the links and also the guide here later after the demo. But if you want to, they're also all covered in this write-up here. This is a still work in progress, and we still need a few things we want to polish before we can share this with the public. But here we covers, for example, step 0, how to create EKS cluster. I just showed them in a very quick way, but if you want to follow them step by step, you can just follow this. Step 1, how to create EFS file system. Everything else is pretty much the same thing as the AWS guide here. And they're all covered in here if you want to use the simple guide. And if you have, once you create your EFS file system, you should be able to see them in your web UI as well. So in here we have EFS, and the first one is the one we just created, and the top part is the file ID. And here we can see that, okay, we have 25 gigabytes being used already. So this means EFS file system is good, it's in good conditions. And another thing that I want to make sure that that everyone is aware is that when you have the EFS file system set up, you will need to be mounted based on your IP address for your nodes. So, for example, if I go onto network, we can see that okay, because I'm in US West and West-2, and I have a few subnets that I can control in my VPC, and based on your node IP address, you want to mount your EFS file system based on your node. So in here, I have 2 nodes. So I've already mounted them in, and one of them is in US-West-2B. The other one is in US-West-2C. So just making sure that your EFS file system is able to access in these 2 subnets, basically. And don't worry about how to do this. This is all covered in the guide later that we will share with the audience. And I just want to make sure that everyone is aware of it. So if you don't have this setup, your node won't be able to control or even see your file system. And the other thing that I want to make sure you guys are aware is the driver. So let's go back to the clusters and go into our cluster. And in here at section 5, add-ons, click on it. We have an add-on called Amazon EFS CSI driver. This is basically the driver for your cluster to have control on your EFS that you have just been created. And adding this add-on to your cluster is also very straightforward. You can just click this Get More Add-on and select this, and make sure you have the right IME role for it. And everything should just work in like a minute. And now we create EFS, and we have also created a EKS. We can go ahead and also view them in our terminal. So on this place, in this local machine, we have a folder called specs. In this specs folder, I have 3 files here: claim.yaml file, pv.yaml, and storageclass.yaml. Let's look into each one. But before we do that, I'm doing this because in Kubernetes, file systems are controlled through a thing called persistent volume. So now we have our EFS file system set up ready. We want to use them in persistent volume so that it can be used in your Kubernetes cluster / your EKS cluster. And these are the files that we want to use to do that. And let's look at each one. In this claim.yaml file, okay, we give it a name, and we call it, and we tell Kubernetes that okay, this is a persistent volume claim, and we want to use 200 gigabytes of it, basically, and we want it to have read and write access. That's pretty much what this means here. And the second file, PV, stands for persistent volume. This is the second YAML file. This is actually we tell Kubernetes, okay, we are using EFS here. So you want to look at the last line here, the volume handle. This should match your EFS file ID. So in this case, we have 005B, blah, blah, blah. And if you go to your EFS file systems, and you can see that this is the file ID that's the same. So make sure that you have the correct file system ID here. Everything else, you can change them based on your needs. For example, you can change the storage size based on your needs. And everything else should pretty much left in default. We also want read and write access to it. So this is good. And the last file, storage class. You don't really need to change this YAML file. This just tell Kubernetes that, okay, I'm using EFS and through CSS and this from Amazon.com. You just need this file here in your place so that Kubernetes know what EFS is. Nothing needs to be changed here. And once you have all these 3 files here, you can just go ahead and install them in your Kubernetes cluster. And I've already run that, but if you want to, you can just do kubectl apply and apply -f for each file in this example. And I have already done that, so you should be able to see them in this command. kubectl get pv, get persistent volume. And we can see that, okay, we have this EFS file system -pv, 200 gigabyte, access is read write execute, and status inbound, that means it's good. Age, it's been 5 hours, so I've run this beforehand, so everything is good. So our EFS file persistent volume is ready and cluster is ready. We can go ahead and actually run a NeMo training job. So let's go back to the directory. Okay.
So I want to do a quick pause here before Wenhan runs that NeMo training job. Would you mind just summarizing sort of what we've seen so far? I think we're on maybe step 2 or step 3. So Paul or Nirmalya, would you mind just kind of summarizing what Wenhan just went over there?
So what Wenhan has just done is he showed how to, say, spin up an EKS cluster on AWS, and then how to configure that with an EFS file system as well. So then now in the second half of this video, we're going to be getting down in the weeds on how you can configure NeMo itself and how you can kind of launch these fine-tuning jobs using the NeMo framework.
Awesome. Thanks for that, Paul. And for those just joining us, welcome to Howdy Partner. If you're just tuning in, this is our weekly Twitch series where we showcase amazing partner solutions for our partners on the Amazon Partner Network. And today we have NVIDIA showing us their NeMo framework and deploying generative AI models on AWS. All right, that's enough of me. Let's get back to the demo.
Okay. So in this directory, we have a folder called NeMo Megatron Launcher. This is a public repo on GitHub. You can clone them if you want to. But this is where we has all these NeMo functions and the training configurations set up in here. So let's go into this NeMo Megatron Launcher. And in here, you want to go to a folder called Launcher Scripts. Okay. In this Launcher Scripts, we have several files here. The first file we want to look at is the main.py script. You don't need to change this file at all, but just keep in mind that at the very end, after everything is set up, all the configuration files that you have changed, all you need to do is Python 3 main.py. That's all you need to run, and it will automatically create the Helm charts for your job, and you'll save the results in the results folder, and you don't really need to do anything here. So just make sure that once you have everything set up, this is the script that you want to run. But before we do that, we want to quickly show you guys what files that you need to change for today's demo. And before that, in today's demo, we will be using this, as you guys can see, Llama 2 7b.NeMo model. So this is a foundation model in .NeMo format, and this has not been customized at all. So in today's demo, we will show you how to fine-tune this model using LoRa, and we'll show you an example comparison between and after the fine-tuning, or you can call it customization step. And the very first file that we want to make sure we are looking at is in this config folder, there's a file called config.yaml. In YAML file. We want to make sure there are a few things that we want to make sure we are setting up. So at line 3, cluster, we want to make sure that it's in Kubernetes, and this can be other things based on your cluster. And at line 9, PFT, this is the thing that we want to run today. So in this case, we are running Llama, so we want to call it llama/squad. Squad is the data set that will be used to fine-tune or to train the model, today's demo. And going down at line 26, stages, this is where you actually tell NeMo, okay, what we want to run. So we have several things here that you can do. For example, data preparation, the step that how to prepare the data set. We have another one for training. This is how you actually retrain a foundation model, the one that we just saw at the beginning. But in today's demo, we want to run line 35 PFT. This is the lower job that we want to run, so that we want to uncomment this part. If you want to use the other one, just uncomment the other one and comment the rest. And go to line 43. This is the container that we will be using for our cluster. We're using 23.11 in this case today. In this case, keep in mind that we release a new framework or a more updated framework every once in a while, and we will have the latest feature and changes and bug fixes in this container. And in today's demo, we'll be using this step. We'll be using this container. And everything else here should be left in default. You don't really need to change anything else. Oh, then another line, 37. Make sure that you have cluster type in Kubernetes, just like line 3. That's pretty much it. Okay, so this is the first YAML file that we look at today. The second YAML file we want to look at is for fine-tuning. So as you guys can see, the previous config.yaml file is a pretty general. It doesn't really tell NeMo how do you want to control your training job. This just tells NeMo, okay, this is what we want to run. But in this config folder, there's another folder called PFT. And in this folder, there are 3 models here, GPT-3, Llama, T5. We'll be using Llama today, so go to Llama, and we can see there is a file called squad.yaml. But before we look into this, I just want to quickly point out that in this config/folder here, we have all the other folders along with this PFT folder, and they are also for your different stages that we just look at in the config.yaml file. Remember, we have the data preparation with the training, and their config files is here. Data preparation is here, training is here, prompt learning is here. But in today's demo, we're looking at PFT. All right, I just want to quickly point out that. And okay, let's go back to the PFT Llama squad YAML file. In here is what you actually want to change for your training job. So this is the training parameters where you change your training parameters. And for example, at line 14, we tell it, okay, we have 4 GPUs. At line 13, we have 2 nodes. And line 17, we tell NeMo we want to use BF16 in this case. And line 23, 24, how many steps you want to do a validation check. And at the bottom, it tells you, okay, how do you want to save your checkpoint? And you can say, okay, we already stopped checkpoints, call back. There are a lot of other specific parameters in this YAML file that you can change based on your needs, but everything else can be left in default because we are not changing anything in Crazy today. Everything here in example should work. And moving down at line 56, this is where we specify, okay, what parallelism technique we want to use. In this case, we're using tensor parallelism. Parallel size is 8. 59, pipeline parallelism is 1. 61, global batch size is 8. Micro batch size is 4. Yeah, and also, how do you want to use the restore path? You can change them here based on your needs. We also have sequence parallelism if you want to try that out. And there are several other things at the bottom. But for today's demo, the default example script provided in the NeMo GitHub repo is good enough. And this is the second YAML file that we have just changed. And these are the only 2 files that we are changed here. The other thing that I want to show you guys.
So we're going to take a quick pause here as Wenhan just finished that last step. So we have a question in the chat that we'd like to quickly address here. Let me pull it up as I lost it. So the question was, why not use FSX for luster instead of EFS? So Brian, did you want to take a stab at answering that?
Sure. Thank you for the questions about storage. There are different storage options that we can look at. So when we look at EFS for this solution, we could also look at FSX for luster. Both have EKS drivers, CSI drivers that we could attach. So depending on the storage solution that you want to look for, you can try both of those, and both of those should work. As far as the other questions in and around S3, S3 is great for storing your data sets too. There are options, but some of the big differences of using EFS and FSX is the high availability across availability zones. So just wanted to see if there's any questions about storage before we keep going.
Thanks for that, Brian. And yes, definitely keep the questions coming. We love that the chat is very active. This is great. All right, so I'll put the video back just a couple seconds and we will continue with the demo.
And this is the second YAML file that we have just changed. And these are the only 2 files that we are changed here. The other thing that I want to show you guys is where do we actually keep the Kubernetes manifest files. So let's go into, there's another folder called NeMo Launcher in here. And inside there's a folder called core, and there's a folder called Kubernetes_templates. And in here, we have a folder called TFT. So let's look at that one. Here we have 4 YAML files. These files are basically where you set up your Kubernetes. And the one main file that we want to look at is tft.yaml. In this YAML file, this is actually how you set up a Kubernetes manifest. But I just want to quickly go over it. So line 31, make sure that you want the wrong torch. You want to do torch wrong. How many nodes, how many GPUs, and what script that you want to run this on, and resource request, how many NVIDIA GPUs you want to use. And line 39 shows you, okay, what path that you want to mount it. And remember, previously we have created that EFS for persistent volume. And here is where we want to use it. So let's scroll down to line 50. Okay, this has a name as workspace, and at line 51 we have persistent volume claim. This is, and then at line 52 we want to make sure that we're using this claim, the one we create for EFS. And this EFS file system will be mounted in this at line 39 in this path on each node once the job is up and running. And everything else should be left in default. Really, nothing else needs to be changed. Yeah, and we have all these examples written up for you on the GitHub repo. Okay, that's the last thing that I want to show you guys before we actually jump into the training. So,
and just really quickly, that GitHub repo that Wenhan mentioned, Paul was nice enough to provide for us, so we did drop that in the chat there. So be sure to visit that link to check out that repo that was referenced.
Now we have everything set up. We can just do this Python 3 main.py command here. I have already run this beforehand. So after you have run it, you will automatically create a Helm chart for this fine-tuning job. So if you go to Helm list, you can see that, okay, we already have this thing set up and running. And if you go to kubectl get pods, okay, we have, 2 workers, one for each node, and they're both running for 135 minutes already. I run this before I came in today. So everything is up and running. And once you have these running, you can also see what each pod is doing. You can see the GPU utilization if you can log into one of the pod. And let me quickly get the command for it. So we quickly summarize here. We have covered step 0, step 1, and now we are at step 3. And I want to go to model training. And in here, I want to use a command here, just this. This command allows you to SSH into your worker node. So in today's example, we want to go to worker 0. Okay, we're in successfully. And in here, you can use the command called NVIDIA -SMI. This command shows you, okay, I have NVIDIA 810G GPU, and I have 4 of them. And this is the memory usage. We're using 12 gigabytes on each, and out of 24 gigabytes. And this is the power usage. This is the GPU utilization percentage. Everything, all of them are at 100%. That means everything is actually running and training a model for you. And if you have the GPUs on your machine, but everything is in idle, so nothing's running, you should see 0% here. Okay, so now we are in this pod. We can make sure that it's running. We can exit out. And let's go back to our local machine here. And once you have the job submitted up and running, you will see a folder called results. Now we'll quickly go into this folder. In this folder, there are several files here. The first one is Kubernetes_template. This is the Kubernetes manifest that being generated inside the under the Helm chart that is created in NeMo. And the other stuff are just logs. This YAML file is the one that we have seen previously for fine-tuning. It's just here for your references. And what I want to show you is this results folder.
Let me get off mute there. Before we get into the results, we have a little bit. So Wenhan talked just now about GPUs, and we see a little bit of data there on the screen about the GPU, the utilization and all that. So Brian, I wanted to ask you, you mentioned there's usually questions about which instances to use and things like that. So is there any guidance on different GPU options or instance options?
The good thing is that we do have GPU options. And so selecting the right GPU for your workload can vary, and some of it is a little trial and error, but here's some things to think about. When you're training your model, you could have an EKS node group comprising of different GPUs, depending on how many parameters you may have and depending on how dense your data set is. So some things to consider. Today, we talked about the G5 instance that was training the model. There's also instances that you could kind of scale up into that can handle more denser, quicker training. Some of them are our P3 and our P3DNs. That's powered by the V100 GPU. It can kind of step up into that a little bit more. You think about that for the P4D, that's the A100 GPU, and that can top out at 320 GPU memory in gigs. And then you can go all the way up to the P5, which is the new H100. That's 8 GPUs and 640 GPU memory. There's also other considerations. You could create a node group comprising of NVIDIA GPU nodes that you can use for inference too. So as we kind of talked about today, you could use the G5. You can also use the G5G. So understanding how to map some of these, the GPUs to the workloads, things to consider is the cost. How long would it take your training job to run? How fast do you need that, and how dense it is? So just some things to think about. If you have any questions, I'd like to see what you have in chat. We'll respond to those.
Thanks so much, Brian. Thanks for that guidance there. All right, so Huang, take it away with the results from our training here.
In this results folder is what actually being generated from the training. And in here, we can see that we have all these logs from NeMo. And I want to quickly mention that NeMo is built on top of a PyTorch Lightning. So some of these logs outputs are very similar to PyTorch Lightning, if you're familiar with that. And we also have event files for test board if you want to look at them later on after the training. And we want to look at a folder here called checkpoints. In this checkpoint folders, we have firstly a file called llama tuning LoRa-NeMo. This is the checkpoint that actually being saved. But because we are running in 8 GPUs and NeMo has this distributed checkpoint feature, so that everything can be separated in 8 GPUs. So for each GPU, we have a checkpoint for it. But in today's demo, we can just use this -NeMo format. This can be directly used in NeMo inference. Everything else here, these folders, they are in checkpoints. So you can later on convert these checkpoints into this -NeMo if you want to, and you can modify this behavior in the config file that we showed earlier. But this is how we set up in today's demo. And now that it's been running for one hour, and we have this -NeMo output here, that means it's at least finished or 10 steps per training. And let me quickly go to an example here. Okay. On the left side is what we have for the foundation model. I just want just quickly focus on the left part. And in this example here, we asked the demo a question: which NFL team represented the AFC at Super Bowl 50? And the context we give to the demo to the model is this. All right. And what we want the demo to say is this: it's Denver. But the model in predictions, it doesn't even have any outputs. That means the model doesn't even understand what the question is. It doesn't even understand the task at all. But that's before you fine tune it. On the right side, same question, same context. But in this case, we're giving out, but in this case, model is able to predict the right answer, just like the label showing here. So that's what we want customization or fine tuning to do. It fits a specific text based on your needs. And this is just a quick example in here. And you can test this in any data set you want to. But there are a lot of other examples at the bottom for left and right. I just show you guys the very first one so that you guys can see what's actually going on. We have 10,000 questions tested for your model, and you can build, you can print out a summarization score at the end to see how your model is doing after the fine tuning. And that's the difference between before and after the fine tuning part. But that pretty much covers today's demo. We have all these up and running already. We cover how to create EKS. We cover how to create EFS, how to use them in NeMo, how to make sure that your EFS file system is accessed to all your nodes, and what files that you need to modify to run a training job on NeMo, and how you and what the results look like. But that pretty much covers the demo today. Let us know if you have any further questions. Thank you for watching.
Yeah, please do drop those questions in the chat. We have people here ready to go, ready to answer those for anything that you saw here today. That was a well-timed demo on the Super Bowl question, because the Super Bowl is coming up this Sunday. Feel free to drop in the chat what your predictions are. But aside from that, that was great. That was really cool to see not only this right here, the data behind the different GPUs and the utilization, but also the before and after, before fine tuning versus after fine tuning and the results of that. So thanks for that. So Nirmalya, Paul, anything you want to touch on, what we saw here, summarize it, any follow-ups?
So one thing I would like to say is, and then Paul, you can chime in. He mentioned, I don't know, you followed that nuance. He mentioned .NeMo llama file. So that's something just I want to, pick audience's attention. So it's llama, which we took from the Hugging Face and we optimized through the NeMo framework. Remember, that's what we talked about in the beginning. So that's what we feel like, if you are passionate about using community models, we like to support you, and we optimize through the pipeline of the NeMo. So what you saw is essentially .NeMo llama file, which we converted from the Hugging Face format to NeMo checkpoint. And then we used a LoRa technique, BFT technique, and you saw the results before and after the fine tuning. And from the NeMo framework, hopefully you saw there are very few lines of code. Of course, the process took a long time, but once you get into it, once the clusters are set up, we tried to make it as simple as possible, and we provide playbooks. Paul, anything to add?
Yeah, just to add on about some of the benefits of NeMo framework. Like once you have your compute and you have your kind of data set ready, you're really just altering these configuration files and then just telling like the configuration, like, hey, I want to run LoRa, I want to do p-tuning, I want to do supervised fine tuning, I want to do like I want to use SteerLM, I want to use, say, DPO. So what you're getting is a very scalable and performant way of using all the latest state-of-the-art techniques for fine tuning, and you don't have to get to the PyTorch level to use these state-of-the-art techniques.
Amazing. Thanks, Paul. Thanks, Nirmalya. All right. After the demo, did we have more slides to show, or did you want to show anything else today?
No, I think that comes to a prepared content. Now we can open up for Q&A, whatever comes in the chat, right? Of course, we will end up with the GTC slide as a call to action, but probably that will be the final slide. But do you have any questions we have not answered so far?
Let's see. I'll check the chat here, see if we've got anything in there. Looks like we don't, so I will go ahead and add in this GTC slide. Paul, I saw above your head there, I see a little floating thing there, and I was going to ask you, but it looks like we have a slide for it. So yeah, please tell us a little bit about GTC.
Of course, GTC is a signature event of NVIDIA. It's a user conference, lots of speakers from NVIDIA outside, and Amazon happens to be a Diamond Elite sponsor this time. So we like you to attend. I believe this is after a long time we are, organizing this in person, but you can also attend virtually. So, try to join and see what's happening on the AI, how we think about the AI, and not only how we think about the generative AI in particular, how we think about with the community. And just what I want to emphasize, if you look at our sessions, if you look at the breakouts, you will see not only the hardware acceleration and those kind of topics, but you will also see purely software focused, generative AI focused, LLM focused topics. So all I'm trying to say is we'll get a diverse set of choices. Given your appetite, you can choose the right sessions for you.
Super excited to hear that it is back in person.
Correct.
That's really exciting. Of course, it'll be available virtually as well.
Yes.
Awesome. Yeah, that's great. I did get word here that apparently early bird discounts end today. So if you are interested in attending, that might be something that you want to take advantage of. So definitely be sure to check that out. We did have a question. Thank you for keeping the questions coming in. Will there be info about NeMo at GTC?
Of course, there'll be a lot of info about NeMo. There'll be, I mentioned NeMo has many flavors. NeMo framework you had today, and you got a flavor of NeMo models, community models in that case. You will hear about a product called NeMo microservices. We are trying NeMo framework is a little lower, like you saw the Python library. But if you are really of one of those users who are much more familiar with or comfortable using REST API, so you will be seeing another layer of abstraction. So we'll call it NeMo microservices. And then you will see newer models coming out, NeMo retrieval augmented generation. So there are lots of announcements you will definitely find, and I will encourage you to join and participate and see not only the announcement from us, but also announcements from the partners, what they're doing with NeMo.
Mm-hmm. And then as GTC approaches, there's still many ways to get your hands on NeMo and then try to build some more subject matter expertise in using it. I can see this was linked in the chat. Like, we put a lot of hard work into creating these playbooks that take you through the end-to-end process of what NeMo is. So if you can click on that link there, is what you'll see is a step-by-step guide that'll take you through the kind of process for everything that NeMo has to offer, from say like data pre-processing with data curator, from say configuring like your hyperparameters properly in NeMo. How do you do the model pre-training? How do you do parameter efficient fine-tuning? How do you properly go through supervised fine-tuning? It's like we have a lot of great resources that take you through step-by-step on how to leverage what NeMo has to offer.
Definitely. Okay. Thanks for that, Paul. And another note on how to access NeMo on AWS. I'm going to drop in a banner here. An easy way to get NeMo on AWS is to go to AWS Marketplace, and specifically the NVIDIA AI Enterprise offering there. So you see it on the banner. We'll go ahead and drop that in the chat as well. It's really, Marketplace is a really easy way to get solutions like these up and running. So definitely check out the AI Enterprise listing from NVIDIA there.
Wonderful. Anything else? One of the questions we get always is it always necessary to fine tune your model, or when should I be thinking, retrieval augmented generation? When should I be thinking fine tuning, or combination of both? This is a very common question these days, and probably Paul, do you like to take that question?
Mm-hmm. Yeah. So say if you take an open source community model like say Llama 2 or Mistral, like these are going to be very high quality models that you can leverage, but maybe they're not fine-tuned directly on your organization's use case. So say if you have a bunch of, I'm going to use the term unstructured text, maybe you have a bunch of, say, books or information that's not really going to be present in the original Llama or Mistral model. We have a process called continued pre-training, where you can, say, pre-train your model on that set of unstructured information. And then to speak more on, say, fine-tuning versus RAG, the way that I would first think of fine-tuning as fine-tuning, it's a great way to, say teach your model more information, but then more specifically to help adjust the way you want your model to have in output. Like, say if you want to get a highly specialized model that maybe can convert natural language to SQL, what you can do is you can, say, take in, you can collect a bunch of data on, say, like natural language queries, and then the completion of that would be the SQL query. You can fine tune your model with supervised fine tuning or with PEFT to make sure that your model has a much better understanding of how to take in natural language inputs and then produce the SQL output. And then with RAG is something where you're able to bring in a lot of different constantly updated information to your model. Whereas, say, if you have company FAQs or documentation that's updated every single day, what you're not going to want to do is fine tune your model every single day on all that information, because that's going to be very computationally intensive and you're going to need a lot more resources to do so. So then you can still use, say, RAG in combination with fine tuning, but you don't necessarily have to choose one or the other.
Thanks for that, Paul. I know for me, that's a question that I always come up on too. Like, what are the advantages of both of them? Which one do I choose? So thanks for tackling that with the RAG versus fine-tuning approach.
We do have one question in the chat for my NVIDIA friends. Are there going to be specific sessions at GTC that will focus on NeMo, and can attendees get their hands dirty with NeMo with AWS?
Something we'll look at. Definitely, if there is an AWS hands-on session on the GTC, I am not at this time aware of that, but definitely let me take a look at and see if there is an interest, if we can accommodate. We know we have Launchpad, and we know, those are the kind of sessions we enable. Probably something we can work with AWS jointly, right? Because we need the compute availability. That's the key, and compute availability on AWS to experience the AWS specific, kind of interconnects and all that thing. So I'll take that AI and update here.
Awesome. Well, let's see. It looks like there are no further questions in the chat here. I think we got them all. Yeah. Any last remarks from the NVIDIA side?
I think no. Thank you for the AWS team for hosting us. We really, really enjoy and appreciate the partnership with AWS and Amazon as a whole. As you heard me now, probably third time saying, this is one of the best partnerships we have. And, not only we facilitate our framework, also Amazon themselves use the framework. There is no more satisfaction than that. And the audience and the listeners and the viewers of the stream, thank you all. Please use NeMo. Try to find the right solution. Hopefully we have found NeMo for you today, and you take it and you drive it to your creating your custom model. If you have any questions, please reach out to us. We'll be delighted to answer your questions in a prompt fashion. Thank you.
And I just want to thank NVIDIA for our ongoing partnership. What we're doing together is quite amazing on several different fronts. So I work with some fantastic people at NVIDIA. So thank you for your partnership. Thank you for your lean in. And I think we're just getting started.
Very exciting. Very exciting. Well, just to extend that thanks, Nirmalya, Paul, and Charlie as well, who was on earlier. Thank you so much for being on the show, for taking the time here today to show us NeMo. It was really awesome to see this live and get a demonstration. So thanks so much for being on the show, and hopefully it's not the last time. I know NVIDIA's got a lot of things cooking up, and we'd love to have you on the show again.
Yeah,
Thank
would
you.
always love to talk more about NeMo.
Awesome. All right. And to the audience, as Nirmalya mentioned as well, thank you so much for being engaged, for using the chat, just for attending here today as well and giving us your time. We're here every Wednesday at 5 p.m. Eastern time. I'm in New York on the East Coast. If you're in the Pacific, that's 2 p.m. Pacific time. But every Wednesday at this time, we'll be here next week. So be sure to tune in. All right. Thanks, everyone. Have a good one.
Thank you.